Hello, Coach Travis here with another calculus video. Alright, so we got a fun one here because it involves drawing a picture, and I always love drawing pictures. So we want to find the equation of the line tangent to the graph of -3 times the cosine of x at the point where x is equal to -pi/3. So I mean, I guess in all honesty, you don't have to draw a picture of this, but you know, what fun is that if you don't draw a picture, you know? So let's kind of imagine what's going on here. So all right, so what we got drawn here I'm using GeoGebra here. We've got the graph of -3 times the cosine of x drawn, and so they're saying that x is -pi/3. And so -pi/3 is about -1. So I'm trying to find the tangent line about at the point right there. But hey, as long as I've got GeoGebra going here, let's be more exact about it. So here's what's cool about GeoGebra is I can just type in, I want the x coordinate to, I'm typing in a point here. So I'm entering the x coordinate, and the x-coordinate I want to be pi/3. And the y-coordinate, you might say, okay, what the heck is the y-coordinate going to be? Well, one way to figure out the y-coordinate is to put -pi/3 into this function. And you should be able to do that. And if you do that, then you should get, like, I think, -1.5. So I shouldn't have spoiled it for you. I should have made you think about it. But what's really cool is actually GeoGebra can do the work for you, because notice I named this function f, so just like the problem did. And so I'm just going to type f of -pi/3. And sure enough, bingo, GeoGebra puts the dot right on the curve where it's supposed to be. Oh, and you can see that those of you that paused the video and tried to figure that out in your head, good for you if you got a -1.5. So all right, so we're trying to find, okay, oh, now I can try drawing a, I can try drawing a tangent line at that point. So this will be terrible because I'm bad at, I'm not drawing tangent lines. Drawing good tangent lines is not one of my strongest abilities. But you know, I'll do my best here, or I'll give it a try. I'm not afraid. I'm not afraid to draw terrible pictures. Okay, so anyway, so we get, you know, we can imagine a tangent line right there, like so. And basically our challenge in this problem is, what is the equation of that line? So what's cool is what we're going to do is we're going to use calculus, and we're going to find the equation of that tangent line, and then we can have GeoGebra draw it. Because Coach Travis is terrible at drawing lines. But GeoGebra is awesome at drawing lines. So what we're going to do is we're going to find the algebraic equation for the correct tangent line, and then we'll have GeoGebra draw it. And it should be close to what I drew, but we'll see that it's probably not the same because I'm not so good at drawing the pictures. All right. So let me see here. Okay, so let's get rid of GeoGebra, but I'm going to leave that line there because I want to be able to compare my prediction with our final answer. But let's see. But how are we going to do this? Okay, so we know that, yeah, it tells us kind of the form it wants us to use. It says it wants us to write the answer in point-slope form. And so point-slope form is going to be, let me see, maybe I'll write it over here. Point-slope form is going to be y minus y naught is equal to m times x minus x naught. And if I were you, I'd be saying, well, wait, what are these x naughts and these y naughts? What these are is these are the coordinates of the point you know. So in order to write down the equation of a line, you need to know a point and you need to know the slope. And so the x naught and the y naught, those are the coordinates of the point that you know. So oops, I want my blue pen back. So in our case, we've got y minus, I'll leave a blank, and then I have m times x minus, and then I'll leave a blank. And so what was the point that we knew? So I can bring GeoGebra back if we want. The point that we know was the x coordinate was, now GeoGebra says it's negative 1.05, but in reality we know it's negative pi over 3. So the x coordinate is negative pi over 3, and the y coordinate is negative 1.5. So that's what I'm going to put in for my x naught and my y naught. So my x naught is going to be a negative pi over 3, because that was what the problem told me. And then the y naught is going to be 1.5. Actually, I like fractions. So I'm going to say 3/2, because 3/2 is the same as 1.5, but I personally prefer fractions, so I'm going to write it that way. Because this one's a fraction, so this one should be a fraction too. It doesn't have to be, but I like it that way. So okay, so that's our line equation, but we're still in trouble here because we don't know what m is. In order to write down the equation of a line, you need to know the slope. So we got the point, but now we need to know the slope. And so whenever you hear the word slope and tangent line in the same sentence, you should think derivative. So that m is going to be the derivative. So, or more specifically, yeah, m is going to be f prime evaluated at negative pi over 3, because the derivative function is the function that if you tell me x, then the derivative function returns the slope of the tangent line at that x. And so our x is negative pi over 3, so our m is going to be f prime of negative pi over 3. So we need to figure out what that is. So because this is still a mystery right now. So we need to figure out what that is. Okay, well let's see. So let's see. So f of x is equal to negative 3 times the cosine of x. And so the derivative of that is going to be, don't tell me, the negative 3 stays there, and then the derivative of cosine, pause the video and think about it. What's the derivative of cosine? The derivative of cosine is negative sine. All right, okay, great. So those negatives will cancel. So we get f prime of x is equal to 3 times the sine of x. And then now the next step is now we need to plug in negative pi over 3, because that's what we wanted. This is the derivative function, and so now if we want the derivative, the slope of a particular tangent line, we got to put in the x-coordinate of the point on the tangent line. So all right, so that's going to be 3. That's going to be 3 times the sine of negative pi over 3. And now you can pause the video and think about what is the sine of negative pi over 3. And in fact, I'm going to have to pause the video. Well, no, I won't pause the video, but I'm going to have to take a moment to think about it. So let's see, the sine of pi over 3 is going to be, sine's the y coordinate, pi over, so I say it's the square root of 3 over 2. Oh, but this is negative. So, and the reason that, so it's going to be, this is going to be equal to 3 times a negative square root of 3 over 2. So the reason I had to think about it was I don't have the unit circle memorized, like I've talked to you before. I don't have the unit circle memorized. I had to draw I drew the special triangles in my head. And that's how I figured this out. And so for you, you could draw the special triangles on paper. I mean, when I was a student, I drew the special triangles on paper to figure this out. And then in my mathematical career, I drew the special triangles on paper so many times that now I'm to the point where I can draw the special triangles in my head. All right, so this slope is going to be negative 3, the square root of 3 over 2. All right, so I think we can write our final answer down here. So our final answer is going to be, let me see, where could I write it so that we can see it with GeoGebra? Because I want to, GeoGebra is going to take up a bunch of the screen here. So that's what I'll do. I'll write it back up here. So we don't really need this anymore. So my final answer is going to be y minus, and I'll have a blank. I'll fill that blank in later because I want to use colors. And then we just found the slope. The slope is negative 3, the square root of 3 over 2. And then we multiply by x, and then minus, and then there's that. And okay, now I'm going to change colors. And so this was a minus pi over 3, and this was a 3 over 2. Okay. And let me circle that. So that is my final answer. But like I said, I wanna draw it on GeoGebra, because to me the problem is not complete until I see it. So I mean, I worked hard to figure this out. And now I want to enjoy the satisfaction of seeing it in action. So okay, so there's GeoGebra. All right, so here what I'm gonna do now is I'm gonna type this into GeoGebra. I'm gonna type this into GeoGebra, and we're gonna cross our fingers and hope that it works. So y minus. Oh, wait. I think I made a mistake, right? Because this should be a minus 3 over 2. I hope I didn't make that mistake earlier. But this should be a minus 3 over 2, because that was the y coordinate. The coordinates of this point, as you can see, this point is in the third quadrant. So both the x-coordinate and the y-coordinate should be negative. So, I don't know if I made that mistake earlier in the video. If I did, I will call it out when I edit the video, but it should be a negative. Okay, so anyway, so I'm supposed to type this in. So, all right, so y, okay, well, the fact that it's a double negative means I can type it in as positive. So y plus 3 over 2 is equal to, and then I've got a negative 3 times the square root of 3, and then we divide by 2, and then we multiply that by x plus, so again it's a double negative, so I'm just going to make it a positive. X plus pi over 3. And poof, look at that. Look at that line GeoGebra drew. It drew a tangent line that is even better than my blue line. My blue line was pretty close, so good for me. My blue line was close, but my blue line was not perfect. But GeoGebra's blue line, you can see that looks like a real good tangent line. And so that provides a check of our work. Like, we did a whole bunch of weirdo algebra to get this answer, and we might wonder, is this correct? How do I know if this is correct? And one way to know it's correct is to draw the picture. Because if you make a mistake here, then what you'll see is this if you make a mistake in the algebra, then when you draw the picture, you'll probably just get some random line that well, it would go through this point, I guess. So it wouldn't be that random. But if you make a mistake in the algebra, then you'll get some line that's obviously not a tangent line. So it's always a good idea to draw a picture, because it's fun to use GeoGebra, and drawing a picture also serves as a nice way to check your work.